2.5, particle motion. For us, AB, we're just look at strictly vertical or horizontal. For 2 dimensions. All right, let's look at a position function. Usually position is S of t, right? We talked about that already, right? Let's say S of t equals t squared minus 2t minus 3. Let's show the position on a number line. On a number line. For t 0, 1, 2, 3, 4. Let's do that. Let's show the position of some object that has strictly horizontal motion. We'll show the position at t equals 0, 1, 2, 3, 4. So let's find S of 0. I got that one. That one's easy. What's S of 1 then? The position for t equal 1. What do you guys got for that? Negative 4? How about S of 2? S of 3? So that means at t equal 3, the position of this object is at 0, right? S of 4. Okay. Let's get number line going. So let's see here. I need to go from negative 4 to 5. So I'm going to put negative 4 here. Let's go negative 3. Try and get these equally spaced. Not too bad. All right, for t equals 0, this object is at negative 3. This object's right here, right? Now from t equals 0 to t equal 1, this object has to go from negative 3 to negative 4. So it's going here, right? Starting at negative 3, going to negative 4. Tell me about this object's position now. To the left of the initial position, right? Would this object have moved backwards or forwards? Could you say move to the left instead, right? Okay. Yeah. All right, and then so at t equal negative 4, or at t equal 1, it's at negative 4. And then it goes to negative 3 at t equal 2. It goes here. What's the change in position from t equals 0 to t equal 2? Change in position is 0, right? Because it's starting in the same spot. What's the total distance traveled from t equals 0 to t equal 2? 2 units or whatever, right? Okay. All right, then t equal 3, we're way up here at 0. Tell me about this movement from t equal 2 to t equal 3. The final position at t equal 3 is at 0, right? But what about that movement? What's happening from t equal 2 to t equal 3? 3 units in one time period, whether it's seconds, minutes, hours, whatever, millisecond, whatever, right? Okay, how is that different than before? One backwards and one forwards, I guess. One to the left and one to the right. Okay. All right, t equal 4, then we're up here at 5. Okay, what about that movement? So is this object moving faster on this time period or this time period? Yeah, between t equal 3 to 4, it's moving faster, right? Covers more ground, same time period. Okay. Let's see here. Well, we'll get back to this a little more. Let's look at velocity. Well, we've talked about a little bit of velocity. What do we know about velocity? Okay, derivative position. So v of t equals s prime t. Well, in this particular case, what is our velocity then? Would that be 2t minus 2? So velocity would be a function in and of itself, but it is related to the position function that was given to us. Okay. Tell me about the velocity of this object. And again, okay, we have derivative, which means velocity equals change in position over change in time, yeah? Because the derivative would be the slope of the previous thing, right? So tell me about this velocity up here based on our position. Well, how about velocity between t equals 0 to t equal 1 and t equal 1 to t equal 2? Tell me about that velocity there. You mean velocity is the same? It changes, but the same rate? What do you mean? Careful about acceleration rate. Let's talk just about velocity. Well, let's get my old buddy here.
I'm applying for a new villain loan. Go by the name of Vector. It's a mathematical term, a quantity represented by an arrow with both direction and magnitude.
Tell me about the velocity between t equals 0, t equal 1, and t equal 1 and t equal 2. Changes, but it's the same. What do you mean? Velocity is a vector, which means it has two things, direction and magnitude, right? So tell me about the velocity between those two time periods. The lengths of those arrows are the same, so therefore they have the same magnitude, but the arrows are pointing in opposite directions, so one's positive, one's negative. So for convenience sake, which one's a negative vector and which one's a positive vector? Which direction is negative, which direction is positive? Yeah, I'd probably go in the negative x direction and be a negative vector, right? So the velocity of this object between here, probably -1 and then +1, yeah? Something like that. How about here? Is this vector positive or negative? And it's a longer arrow, therefore bigger magnitude, right? T equal 3, t equal 4, positive vector, right? Okay, so velocity actually does have direction and magnitude. So it does have direction and magnitude. It's a directed line segment, some people say, or a directed ray. All right. Let's find v of 0 for fun. V of 1. Oh, v of 0, I got that one. That's -2. I'm sorry, v of 0 is -2. V of 1, V of 2. What's V of 1? 0. Okay, V of 2. V of 3. 4. V of 4. Okay. All right. So what does that mean? The velocity at 0 is -2. So at t equals 0, at this moment in time, our velocity is -2. Okay. What's happening then as this object is moving this way? Object's moving left. Why? Yeah, what were we going to say? Careful. The velocity is negative here. And you said the velocity decreases. I don't know. You're already at -2 velocity, right? If you decrease, it means to be a bigger negative number. It's like -3, -4, -5. But at t equal 1, right here, the velocity is 0, right? What does that mean? It's not moving, right? Velocity is 0 means you're not moving. So it's moving backwards, moving to the left, we should say, actually. It's stopped, and then what happens? Change direction, right? So notice here, t equals 0, we have a negative velocity, and we have then a positive velocity, okay? So what does that mean for an object to change directions? I'm not talking about acceleration yet. Let's see here. For an object to change directions, let's do it right now. Let's talk about this in terms of velocity, because that's what we're going to have to do. For an object to change directions, what has to happen? Okay, v of t has equals 0, yep. And then what? Well, think about this, okay? I'm traveling right. So in our case, that means like positive x direction, so my velocity maybe be positive, right? Traveling this way, then I stop, right? I keep going this way. What's my velocity? Positive still. Did I change directions? No, so what has to happen for an object to change directions? The velocity has to equal 0, and then what else? So let's say one way to cover both the situations. You said that it must change from negative to positive or positive to negative. So what must happen for that velocity then? It just changes what? It changes signs, yeah. For an object to change directions, v of t has to be 0, and v of t has to change signs. Good. All right. So at this situation right here, at t equals 0, we have a velocity of -2. Okay. So if we had a number line for v of t, we have 0, and then we have a situation that t equals 1. That's a very important one because that's where we're stopped. We call those critical values. Okay. We'll work on that more later. What type of velocity do I have between 0 and 1? When I say type, I pretty much mean positive or negative, right? Kind of gotten that for a while now. What type of velocity do I have? Negative, right? Between 0 and 1, because our position is going backwards, right? So our velocity is negative. We're moving in this direction, right? We started here, we got to here. We got to walk that way, okay? What's happening after t equal 1? What's our velocity? It's all positive, isn't it? So on our number line, we can tell that we change directions because At t equal 1, our velocity is 0. We put that number on a number line, and then we analyze the signs around it. We know we change directions at that moment. Okay? We're going to work on this a lot more. So, what does v of t equals 0 mean again? Means what? Stopped or not moving? What does v of t being less than 0 mean? Okay, it means negative. What else does it mean in terms of an object moving? And we'll say horizontal motion right now. Yeah, moves left. It means moving left. What about v of t being greater than 0? Moving right. If we have a velocity function, we have to find the velocity at, say, t equal 4, and we get a positive number. We know that at t equal 4, that particle is moving to the right. All right. What's speed, though, guys? Because when I go to Dickinson, I don't say, I travel negative 100 miles an hour. And then when I go to Jamestown, I don't say, I went 100 miles an hour. What is speed? Okay, this is over time. So is this, right? Distance over time, right? Change of position over change of time. No direction. So it's a non-directed line segment. Just magnitude. But what if I know my velocity is negative 47 miles an hour? What's my speed? So what is speed then? Absolute value of velocity. Yeah, absolute value of velocity. I think you guys know what to do, but let's just be more precise about it. Our speed is the absolute value of velocity. All right, look at acceleration now. Acceleration. Well, we know acceleration, a of t, equals what? V prime of t? And we also know that it is s double prime t, obviously. Okay, so in this particular situation, a of t equals v prime of t, which equals 2. Easy polynomials, friendly functions. So what do we know about the acceleration? Is what? Well, 2 units per time period. We don't know if it's meters or, and it's what? Positive. What else? You're always accelerating to the right. Yeah, you're always accelerating to, acceleration is happening to the right. Okay, or if this was vertical motion, acceleration was happening up. What else do we know about it? It's constant. Yeah, it doesn't change. It's always 2 units per time period, right? Okay. All right. So in this particular case, let's make an a of t number line real quick. Now we got 0, and we got 1. I'm going to keep 1 because that's a critical number from velocity. What do you guys know about the acceleration between 0 and 1? It's 2, so what is it? Positive. What do you know about the acceleration after 1? Positive. Okay. All right. So in our situation, the position of the object was moving this way, right? Moving to the left. What does it have to do? Its velocity is negative, but its acceleration is positive. So what's happening then? It has to slow down. So between t equals 0 and t equals 1, velocity is negative, acceleration is positive. It means acceleration is happening in the positive direction. So it's like you're applying the brakes, right? They're opposite signs. They're working against each other. Then what's happening after t equals 1? You're speeding up because your velocity is now positive and your acceleration is now in the positive direction still, right? So you're speeding up, as you can clearly see by the longer arrows, right? You're covering more distance, okay? Until you get in this situation, infinity, right? Pretty soon you'll be traveling the speed of light. Not going to happen. All right, so if acceleration a of t is greater than 0 and v of t is greater than 0, what's happening? Well, speeding up in the, just say speeding up. Okay, what if a of t is less than 0 and v of t is less than 0? Okay, think about this. Negative direction. Say I'm walking in the negative direction. My velocity is in the negative direction. But I'm being accelerated in the negative direction. What's going to happen? You're still speeding up. Just because we have a negative acceleration does not mean you're applying brakes. Okay, you could be pushing the gas in the negative direction. Okay. What if a of t is less than 0 and v of t is greater than 0? So we're walking in the positive direction. Acceleration is going this way, though. Slowing down. Yeah, slowing down. Why are we slowing down? Okay, they have opposite directions, which means they have opposite signs, right? We're slowing down because acceleration and velocity have opposite signs. Okay, a of t, say it's greater than 0, and v of t less than 0. So our velocity is in the negative direction, but acceleration is in the positive direction. You're going to slow down. Okay, if we think about this in vertical motion, strictly vertical motion, say we shoot a rocket with an initial velocity, or we'll say this thing has velocity, moving up. So our velocity is in the positive direction. What's the acceleration? Acceleration is negative. Acceleration would be gravity, right? Pulling the object back down. So what's happening to this object then? It's slowing down until the velocity is 0. Then it's going pretty slow. Then what's going to happen? Velocity is going negative. Acceleration is negative. It's going to speed up. Okay. All right, let's see what I else wanted to cover. Oh, let's make a cool chart. Let's make this a velocity chart. All right. Let's talk about horizontal motion. And we'll go v of t greater than 0. Horizontally, if v of t is greater than 0, what do we got? What are we doing? What's happening? Just velocity. We're just talking about velocity. Just velocity greater than 0. Which way is the positive direction? Horizontally, right, moving right. Okay, what if v of t is less than 0? Moving left. Ooh, what if v of t equals 0? What's one word to say not moving? Stopped. Yeah, not moving is fine. Okay, how about vertical motion then? Vertical motion, v of t greater than 0. What's happening? Moving which way? Okay, vertical motion. Let's talk about v of t less than 0. Moving down. And vertical motion, v of t equals 0. Stopped. Mr. Bodley, That rocket is not stopped at the peak of its flight before it comes down. It's still moving. It's actually stopped for one more moment in time, right? That one instant, it's stopped, and then you're going down. Acceleration. Horizontal. Let's say A of t greater than 0. If A of t is greater than 0, what does that mean? Accelerating which way? Well, greater than 0 means which way? Left or right? Sometimes accelerating means pushing the gas. Sometimes it means pushing the brake. Depends on which way you're moving. I can be moving this way and accelerating this way. It means I push on the gas. I can be moving this way, accelerating this way, and means I push on the brake. That means we're slowing down. Okay. If we have horizontal motion, acceleration is greater than 0 means we're accelerating right. Does not mean you're moving faster right. It means your acceleration is right. What if A of t is less than 0? Accelerating left. And also depends on which way you're moving, whether you're slowing down or speeding up. Okay, let's say acceleration equals t, or A of t equals 0. Acceleration is 0. Not speed, constant velocity. Yeah, constant velocity. Well, I'm going to say v of t is not changing. Okay, I'll say it's constant. I'm going to say not changing. For fun. Okay, vertical motion again. If your acceleration is positive, accelerating what? Up. Okay, acceleration is negative, means acceleration is down. And same thing? Not changing. All right, now let's look at the relationship between the two. Relationship between A of t and V of t. So if I have A of t up here, greater than 0, A of t less than 0, A of t equals 0. Over here, let's put V of t greater than 0, V of t less than 0, V of t equals 0. All right, we'll make this look a little more proper. If my velocity is positive, my acceleration is positive, I'm traveling in the right direction, I'm accelerating in the right direction. What's happening? Speeding up. If my travel is in the right direction, but the acceleration is acting upon me in the negative direction, what's happening? Slowing down. Okay, my acceleration is greater than 0. Oh, sorry, my velocity is greater than 0. My acceleration is 0. Constant. We could say constant speed. That's fine. constant speed. All right, velocity is negative, so our direction of travel is in the negative direction, so we're traveling left. Our acceleration is positive, means acceleration is right. Slowing down. Yep, they're opposite signs, so we're slowing down. If velocity and acceleration are the opposite signs, we are slowing down at that moment in time. Or over an interval too. Okay, velocity is negative, acceleration is negative. Direction of travel is in the negative direction, acceleration is in the negative direction. Speeding up. Velocity is less than 0, acceleration equals 0. Constant speed. What about v of t equals 0 and the acceleration is positive? It's not moving, so stopped. Your velocity is 0, right? Means you're not moving, but acceleration is acting upon you. Think about this. Your velocity is 0. Are you guys traveling right now? I'm like, really? But acceleration, is there acceleration acting upon you right now? But are you moving? You're stopped. You're either like floating up and down, side to side, really. Acceleration is negative. There's gravity acting upon you, right? The acceleration due to gravity is acting upon you. You're not moving. Why? Because your velocity is 0. And velocity 0, acceleration 0. Constantly stopped, all right? Still stopped. All right, to solve some of these particle motion problems, which we'll be working with for a while, and you're not going to do this every single time, but for right now, you'll do this a couple times. Later, we'll be more specific on what we're looking for. And in this unit, there's basically 3 things: particle motion, implicit differentiation, and then related rates. And that's it. That's 3 things. It's all derivatives. Then now we get into chapter 3, graphical analysis. Good stuff. All right. Step 1, find v of t. And then solve for v of t equals 0, which means find when the velocity is 0. Obviously, those will be time periods or times at which the velocity is 0. Why would we want to know when the velocity is 0? When it stopped, what could happen about when it stopped? Yeah, it could change directions, or you could just walk one way, stop, and walk some more, right? Okay, so then number 2, on a number line, analyze the signs between critical numbers. So how do you spell analyze? On a number line, analyze signs between critical numbers. Well, what are critical numbers? That's when v of t equals 0. Those are the t values for when v of t equals 0. Okay. Step 3. Find a of t. And guess what we do? Find when A of t, or solve for A of t equals 0. Guess what step 4 is? Make a number line and analyze signs between critical numbers for A of t. Step 5. On a third number line, compare A of t and V of t for speeding up and slowing down for all critical numbers. That means the zeros you got for V of t and the zeros you got for A of t. 6, we'll probably make a position graph. We did that first thing, right? All right, S of t equals t cubed minus 9t squared plus 24t plus 4. Directions will be do an analysis of the particles direction, acceleration, and motion, and then position. Particles direction, that would be V of t, right? Acceleration, self-explanatory. Motion is comparing A of t and V of t, and there's our position. Okay. What's step 1? Find V of t. Let's be very direct and communicate clearly. V of t equals S prime of t, right? We're gonna write that every single time, and then we're actually gonna find the derivative of S. What would that be? What, 3t squared? Then what, minus and then what was step 2, or second part of step 1? Okay, V of t equals 0, so let's do that. 3t squared minus 18t plus 24 equals 0. Okay, that's finding when the velocity is 0. That we're finding when this particle is stopped. Okay, we'll solve. This is quadratic. Let's see what happens if I factor out a 3. That'd be what, t squared minus 6t plus, is that 8 then? Does that factor nicely or no? What is it, minus 2, minus 4? Okay, for t equal 2 and t equal 4, this particle stopped, right? Okay, so here's V of t. This is step 2, right? Make a number line. I'm just going to kind of arbitrarily put 2 and 4 here. Those are our critical numbers. Those are values at which the velocity is 0. Now, we're going to analyze the sign in between so we can know what direction this object is traveling. Between 0 and 2. Pick a number in here, between here. Okay, 1. Check this out. We have 3 times 1 minus 2. What is that? Well, think about this. This is positive times, what's 1 minus 2? What's 1 minus 4? Positive times negative times negative. Positive. The velocity is positive here. Look at that. You don't have to do much math. Just analyze the products. If I plug in 1, that's negative, positive times negative times negative. How about pick a value between 2 and 4? 3? Okay. When t equals 3, we got positive times. So positive times negative is negative. There we go. We're analyzing the direction. How about after 4? Positive? Positive. So does this object change direction twice? Yeah, because v of t equals 0 and v of t changes signs from positive to negative and from negative to positive. Right? A of t equals v prime of t equals, what would that be? 6t minus 18? We have to set this equal to 0. Ms. Bonnie, is it okay if I just take the derivative of this residual after we factor out 3? Yeah, that's going to be the same thing, right? Okay, well, that t equals what? 3? Okay, now let's make an a of t number line. 0 is here, and I'm kind of going to line things up with my v of t graph. So 3 would be in the middle. And it kind of goes on forever, right? All right. Pick a value between 0 and 3. 1. Okay, what's the velocity or acceleration and t equals 1? Just negative, right? We don't care what it is. Positive or negative, that's all we care about. What about after 3? It's positive because 6 times a number bigger than 3 is bigger than negative 18, right? All right. Make a third number line analyzing a of t and v of t. This is going to be like the motion one. Now, what we do is we drop all these critical numbers onto this graph. So we have 2, 3, and 4. All right, between 0 and 2, positive velocity, negative acceleration. So are we speeding up or slowing down? Slowing down. SD, slowing down. Between 2 and 3. All right, after 2 for velocity is negative. Before 3, we're negative acceleration. Speeding up. And I put speeding up. I write it out, speeding up a lot of times. Because that starts to look confusing after a while. 3 and 4. What's happening? We have negative velocity, positive acceleration, slowing down. We kind of have to slow down and change directions, right? What's happening after 4? Positive, positive, speeding up. And then we can make an S of t graph for maybe like different time periods, right? That'd be easy enough for like t equal 1, 2, 3, 4, 5, whatever. Okay. Questions on that? And usually we show where that position is at critical moments, the 2, 3, and 4, and 0.